Have you ever looked up at the night sky and thought, like, wow, is there another me out there
Oh, yeah.
living a totally different life in like a completely different universe?
Absolutely.
Well, today we're diving deep into that.
Yeah.
The mind-blowing concept of parallel universes.
It's a question that has fascinated scientists and philosophers, honestly, for centuries.
Yeah.
And, as our understanding of physics has grown and evolved, the idea of parallel universes has gone from a, pure science fiction
Right.
to a legitimate area of scientific inquiry.
Yeah. It's amazing to think about. To guide us through this deep dive, we're turning to Brian Greene's book, The Hidden Reality, Parallel Universes and the Deep Laws of the Cosmos.
Great book.
And specifically, we'll be focusing on chapters 1, 2, 3, 4, 5, 6, 7, 8, 9, and 11,
Wow, that's a lot of chapters.
where Greene lays out some of the most intriguing ideas in modern physics.
Yeah, Green does a fantastic job of breaking down these honestly really complex concepts into
Yeah.
pieces that we can all understand.
Yeah.
But I have to warn you,
Okay.
some of these ideas are so mind-bending, they might leave you questioning everything you thought you knew about reality.
I'm ready to have my mind blown.
All right.
So let's start with something familiar, our own universe.
Okay.
The one we can observe.
Sure.
The one we call home.
Right. The observable universe, that sphere of space that we can see,
Right.
began with the Big Bang, roughly 13.7 billion years ago.
Yeah.
But here's the thing. The Big Bang model doesn't tell us the shape the universe takes.
No. Well, okay.
Could be a sphere, a flat plane, or even have the shape of a Pringles chip.
Hold on, a Pringles chip.
Yeah, seriously.
Seriously.
It all boils down to the amount of matter and energy in the universe, something called critical density.
Okay.
If there's enough matter, gravity would curve space back on itself, forming a sphere.
Okay.
But if there's not enough, space could keep expanding outwards, resulting in a shape similar to a Pringles chip.
Okay, I kind of get it, but I can't imagine trying to measure the density of the entire universe. It's not like we can put it on a cosmic scale, right?
Definitely not. But astronomers have spent decades measuring the average density of matter in the universe.
Okay.
And for a while, they thought it was too low for the universe to be flat. But then they discovered something truly remarkable: dark energy.
Dark energy.
Yeah.
That mysterious force that's accelerating the expansion of the universe.
Yeah.
I remember reading about it in Greene's book. It's like the universe is a balloon that's not just inflating, but inflating faster and faster.
That's a great analogy.
Yeah.
And it completely changes the game. This discovery of dark energy in the late 1990s threw a wrench in everything. Suddenly, the universe wasn't just expanding, it was accelerating, pushing everything farther and farther apart.
So how does this connect to parallel universes? Is dark energy somehow responsible for creating them?
Not directly, but it sets the stage. Think about it this way. If space is truly infinite, as some theories suggest, then even traveling at the speed of light, we can only see a limited portion of the universe.
So we're kind of trapped in a cosmic bubble,
Yes.
only able to observe what's within our reach.
Exactly. Astronomers call these regions cosmic horizons. And here's where things get really interesting. If space is infinite, and these cosmic horizons create independent patches, then those patches could theoretically repeat an infinite number of times.
Okay.
Imagine shuffling a deck of cards.
Okay.
Shuffle enough times, and eventually you'll get the same card order again.
Right.
In an infinite universe, the same logic could apply to the arrangement of matter.
So you're saying that there could be another Earth out there with another me having this very same conversation about parallel universes.
That's the mind-boggling concept behind the culted multiverse.
Okay.
In an infinite universe with a finite number of ways to arrange matter, repetition is not just possible.
Right.
It's inevitable.
Wow.
It means every possible arrangement of particles would repeat infinitely, leading to countless identical copies of our universe, scattered throughout the vastness of space.
That's both fascinating and a little creepy. But is there any way to know if space is truly infinite? Couldn't it be incredibly vast, but still finite?
That's a key question, and it leads us to another groundbreaking idea in modern cosmology: inflationary cosmology.
Okay.
It suggests that in the fractions of a second after the Big Bang, space underwent a period of incredibly rapid expansion,
Great.
smoothing out the early universe and explaining the uniformity we observe in the cosmic microwave background radiation.
The cosmic microwave background radiation.
Yes,
It's like a baby picture of the universe, right?
precisely. And inflationary cosmology suggests that this baby picture is incredibly smooth and uniform, even across vast distances. But here's the kicker. Many versions of inflationary theories suggest it wasn't a one-time event.
Oh.
Instead, it's an eternal process, constantly creating new bubble universes within a larger, ever-expanding multiverse.
Whoa. Hold on. You're saying that universes are popping up all over the place?
Yes.
Like bubbles in a cosmic bathtub?
That's the essence of the inflationary multiverse. Each bubble universe could have its own unique set of physical laws and constants,
Right.
potentially vastly different from our own.
Wow.
We're talking about universes where gravity works differently,
Okay.
where the speed of light is slower, or where the very fabric of reality is woven from entirely different threads.
That's incredible. But how could these different universes arise? What would make their physical laws so distinct?
To answer that, we need to delve into the world of string theory,
Okay.
a fascinating attempt to create a theory of everything
Right.
that unites the two pillars of modern physics:
Mhm.
general relativity,
Hmm.
which describes gravity on a large scale,
Okay.
and quantum mechanics, which governs the world of atoms and subatomic particles.
String theory, the one that says everything is made of tiny vibrating strings.
That's the one.
I remember that being a particularly mind-bending chapter in Green's book.
It's definitely a wild ride.
Yeah.
String theory not only proposes that everything is made of these tiny vibrating strings,
Okay.
but it also requires the existence of extra spatial dimensions beyond the three we experience: up, down, left, right, forward, back.
Wait, extra dimensions? You mean like a fourth dimension,
Yeah.
a fifth dimension, and so on? Where are they hiding?
That's the million-dollar question. String theory suggests these extra dimensions could be curled up so small that we don't notice them. Imagine a garden hose. From afar, it looks one-dimensional, right?
Okay.
But up close, you see its circular cross-section,
Okay.
a second dimension curled up.
So you're saying our universe could have these tiny hidden dimensions curled up within it?
Yeah.
Like extra threads woven into the fabric of reality?
That's the idea. And the shape of these extra dimensions could dramatically impact the physical laws and constants of our universe. It's like each universe is tuned to a different set of strings, playing a different cosmic symphony. And here's where we connect back to the inflationary multiverse. If each bubble universe in that vast expanding sea of universes has a different shape for its extra dimensions, it stands to reason that each bubble could have a unique set of physical laws. It's like each universe is a snowflake,
Right.
distinct in its structure and beauty.
So you're saying there could be trillions upon trillions of universes, each one fundamentally different, all thanks to these tiny curled up dimensions. That's a lot to wrap my head around.
It's definitely mind-blowing. And this brings us to one of the most fascinating predictions of string theory, the landscape multiverse.
Okay.
This theory suggests an almost inconceivable number of possible shapes for these extra dimensions.
Okay.
More than grains of sand on all the beaches on Earth.
Wow.
Each shape could give rise to a universe with its own unique set of physical laws and constants.
I'm starting to understand why this book is called The Hidden Reality. It's like there's an entire multiverse hiding in plain sight, just beyond our ability to perceive it. But, you know, for all this talk about different universes with different laws, I'm still a bit stuck on one question. Why does our universe have the specific laws it does? It seems incredibly fine-tuned for life to exist.
That's one of the most profound questions in cosmology, and the landscape multiverse offers a potential explanation. Think of it this way. If there are countless universes with varying physical laws,
Right.
then the fact that we exist in a universe that supports life, well, it might not be so surprising. It's simply a matter of probability. We happen to be in one of the few universes where the conditions are just right for stars to form, planets to coalesce, and life to evolve.
So it's like a cosmic lottery. We won the jackpot,
Exactly.
ending up in a universe that's perfect for us.
Yeah.
But is there any way to test these ideas? I mean, it's not like we can hop in a spaceship and visit a parallel universe, right?
Not yet, at least. But the landscape multiverse isn't just some wild, untestable theory.
It makes specific predictions about the nature of our universe.
Okay.
For example, we've talked about dark energy,
Right.
that mysterious force driving the accelerating expansion of the universe. In a single universe model, explaining why dark energy has the specific value it does
Yeah.
is incredibly difficult. But in the landscape multiverse, where there are countless universes,
Okay.
each with different values for dark energy,
Okay.
well, it's not an issue.
Gotcha.
We happen to live in a universe with the observed value of dark energy simply because it's one of the few universes that could support life.
So if we were to find a fundamental reason for the specific value of dark energy within our universe's laws, It would actually challenge the idea of the landscape multiverse.
Exactly. It would suggest a deeper underlying principle governing dark energy rather than just a random selection from a vast range of possibilities.
Huh.
This makes the landscape multiverse testable, even though we can't directly observe those other universes.
Wow, that's fascinating. It's like the multiverse is casting a shadow back on our reality.
Influencing the very laws that govern our universe. But let's shift gears for a moment and explore another way these parallel universes could emerge, this time from the incredibly strange world of quantum mechanics.
Yes, the realm of the very small, where things behave in ways that defy our everyday intuition. This brings us to the many worlds interpretation, perhaps one of the most mind-boggling ideas in all of physics.
I remember reading about this in Green's book. It's the one where every quantum measurement causes the universe to split, right? My brain nearly melted trying to grasp that concept.
It's definitely a head-scratcher, but let's break it down. The central idea of quantum mechanics is that the world of atoms and subatomic particles is fundamentally probabilistic.
Okay.
Things don't have definite properties until they are measured. Think of Schrödinger's cat, famously both alive and dead until we open the box and observe its state.
Right. I remember that example. It always makes me think of those old choose-your-own-adventure books, where the story splits depending on your choices.
That's a great analogy. In the many worlds interpretation, every time there's a quantum measurement, the universe branches into multiple copies,
Okay.
each representing a different outcome of that measurement. So Schrödinger's cat isn't both alive and dead in the same universe.
Right.
There's a separate universe for each possibility.
Gotcha.
One where the cat is alive and one where it, unfortunately, met its demise.
So you're saying every decision we make, every coin flip, every time an electron is measured, creates a new universe. Doesn't that seem a bit extravagant?
It does. And Green acknowledges that the many worlds interpretation is a very radical idea, but it's also remarkably elegant. For example, it eliminates the need for the wave function to collapse, a mysterious and unexplained process in other interpretations of quantum mechanics. In the many worlds interpretation, the wave function simply continues to evolve, branching into multiple realities along the way.
Okay, that's an interesting point. But how can these universes branch off without us noticing? Do we really split into multiple copies every time we make a decision?
That's where the concept of decoherence comes in.
Okay.
The idea is that these newly branched universes quickly become decohered from our own,
Okay.
meaning they no longer interact with our branch of reality. Think of it like tuning a radio.
Okay.
You can only listen to one station at a time, even though countless other radio waves are passing through you.
So it's like these other universes are on different channels,
Yes.
and we're stuck on our own specific frequency. But still, I have to admit, the idea that countless universes are constantly branching off from our own just because of quantum measurements is incredibly strange. Are we really supposed to believe that?
It's definitely a challenging concept.
Yeah.
And even physicists who support the many worlds interpretation acknowledge its strangeness. But remember, the strangeness of quantum mechanics itself is well established. We're dealing with a realm where particles can be in multiple places at once, and information seems to travel instantaneously. Perhaps the many worlds interpretation, with its branching universes, is simply a reflection of the inherent weirdness of the quantum world.
I suppose that's a point. If the universe is already strange at the quantum level, maybe a multiverse isn't so far-fetched after all. But what are the implications of the many worlds interpretation? If it's true, what does it mean for our understanding of ourselves and our place in the cosmos?
Well, for one, it suggests that reality is far vaster and more complex than we ever imagined. It's not just our single universe, but a constantly branching multiverse with every possible outcome of every quantum measurement being played out somewhere.
So there's a universe where I chose a different breakfast this morning, and another where I won the lottery last week. The possibilities seem endless. But doesn't that make our own lives less significant if everything that could happen is happening somewhere?
That's a profound question, and it gets to the heart of the philosophical implications of the many worlds interpretation. It challenges our notions of identity, free will, and even ethics. If all choices are being made in some universe, does it diminish the significance of the choices we make in our own reality?
It's a lot to ponder. But that's the beauty of exploring these ideas, isn't it? It forces us to confront the limits of our understanding and to consider possibilities that might seem outlandish at first, but could turn out to be fundamental aspects of the universe. But before we wrap up our exploration of parallel universes, I remember Green discussing one more type of multiverse that I found especially fascinating: the holographic multiverse.
Yeah.
It connects to some of the ideas we were discussing earlier about black holes and information.
Yes, the holographic multiverse. It's one of the most mind-bending and counterintuitive concepts in physics. It suggests that our universe might be like a giant hologram,
Right.
where all the information about everything in it is actually encoded on a distant two-dimensional surface.
Okay, I'm going to need a little help unpacking that one.
Yeah.
How does the idea of a holographic universe even come about?
It starts with black holes.
Okay.
Stephen Hawking showed that black holes aren't just cosmic vacuum cleaners.
Right.
They also have entropy. That means they have a hidden information content. But here's the strange part. That information isn't related to the black hole's volume,
Okay.
like it is for ordinary objects. Instead, it's proportional to the area of its event horizon,
Right.
that point of no return,
Gotcha.
where even light can't escape.
That does seem strange. So you're saying that a black hole's information is stored on its surface rather than inside it. How is that even possible?
It's a profound question that has led physicists to formulate the holographic principle.
Okay.
This principle suggests that the information content of any region of space is limited by the area of its boundary, not its volume.
Okay.
Think of it like a room.
Okay.
Imagine you want to store as much information as possible in that room,
Okay.
filling it with books, hard drives, servers, anything you can think of.
Okay.
But the holographic principle says there's a limit to how much information you can store.
Right.
And that limit is determined by the area of the walls, floor, and ceiling.
So it's not about how much stuff you can cram into the room, but about the surface area of the room itself. That's wild.
It is. It suggests that the information about everything inside that room is somehow encoded on its boundary like a two-dimensional hologram,
Right.
projecting a three-dimensional image. Now, if this principle applies to any region of space, some physicists believe it could apply to the entire universe.
So our entire universe, with all its galaxies, stars, planets, and even us, could be a giant cosmic hologram. That's truly mind-boggling.
It is. The holographic multiverse suggests that everything we experience, all the matter, energy, and forces in our three-dimensional universe, might be a projection of information encoded on a distant two-dimensional surface. It's like we're living in a cosmic movie,
Right.
where the screen is actually the boundary of our reality.
That's absolutely incredible. But where is this two-dimensional surface located? Is it like a giant screen surrounding our universe?
That's a question that physicists are still grappling with. The exact nature and location of this holographic boundary are still a mystery. But intriguingly, there's some theoretical support for this idea from string theory.
String theory, the one with all those extra dimensions. How does that connect to the idea of a holographic universe?
While in some versions of string theory, physicists have shown that a universe like ours with gravity and other forces can be mathematically equivalent to a simpler, lower-dimensional universe without gravity, where the information is encoded on a boundary surface.
So it's like string theory is providing a mathematical dictionary
Right.
to translate between the holographic universe and the lower dimensional universe where the information is actually stored.
Exactly. It's a remarkable connection that suggests the holographic principle might be more than just a mathematical curiosity. It might be a fundamental feature of reality itself. It's as if our universe is a beautifully rendered 3D projection, but the true source of the information, the blueprint of our reality, lies on a distant 2D surface.
I have to admit, this holographic multiverse is one of the strangest concepts we've discussed today. It makes you wonder if there's even a limit to how bizarre the universe can get.
It certainly does. But even though it sounds like science fiction, remember, it's emerging from some of the most profound and well-established theories in physics. We're not just making this up.
Right.
We're following the trail blazed by some of the brightest minds in science.
Well, after exploring all these different types of multiverses, from the quilted multiverse to the inflationary multiverse to the landscape multiverse, and now this incredible holographic multiverse, I have to ask, what are your personal takeaways from all this? What stands out to you the most?
You know what strikes me is that despite the mind-boggling nature of these concepts, it's truly inspiring to see how human curiosity and the scientific method can lead us to contemplate such profound ideas. We're pushing the boundaries of knowledge, peering beyond the veil of our everyday perceptions, and glimpsing the hidden machinery of the cosmos. It's a testament to the power of human ingenuity.
I couldn't agree more. And for our listeners who might be feeling a little overwhelmed by all this multiverse talk, is there a single key takeaway you would want them to leave with?
I would say that the most important thing to remember is that the idea of parallel universes, while still highly speculative, is grounded in some of the most rigorous and successful theories in physics. It's not just a philosophical fantasy, it's a possibility that emerges naturally from our attempts to understand the universe at its deepest levels.
Absolutely. And for those who are eager to learn more, Brian Greene's book, The Hidden Reality, is a phenomenal starting point. It's a journey that will challenge your assumptions about reality and leave you with a sense of awe at the vastness and strangeness of the universe.
I wholeheartedly agree. It's a book that can spark a lifelong fascination with the mysteries of the cosmos.
So until next time, keep looking up at the stars and wondering what might be out there beyond the limits of our imagination. Perhaps in some distant parallel universe, another version of you is doing the same, gazing back at our own universe with the same sense of wonder and awe.
It's a thought-provoking possibility, isn't it? The multiverse, if it exists, is a tapestry of infinite possibilities, and we are just beginning to explore its intricate threads.